So we have seen what is data traffic and traffic descriptors and traffic profiles, right? So today we are going to see what are the categories that are present in congestion control. So open loop congestion control is used for preventing the congestion control, right? So closed loop congestion control is for what? Removing the congestion control, yes or no? So we have different policies here. If you see open loop retransmission policy, window policy, acknowledgement policy, and discarding and admission policy. So if you see all these policies, you will get to know how we are going to prevent the open loop congestion control, right? So whenever we apply some particular mechanism or the policies, the congestion control will be handled from source to destination by using that policy so that it will prevent the congestion. So first one is retransmission policy, right? So retransmission is nothing but whenever we cannot avoid, like, if what is meant by retransmission. So if we are sending a data packets from sender to receiver, so if the receiver will not reach the data packets from sender, or it won't send any particular acknowledgement, so what sender will do, sender will wait for some particular time period and then again it will retransmit that particular data packets, right? So that is known as retransmission, right? So if sender feels that the sent packets is lost or corrupted, then also the sender will retransmit the data packets, right? So when we are doing this retransmission policy, there may be a chances of congestion here, right? So that we are using a good retransmission policy that will prevent congestion. So here in this policy, what we will do, we will set timers for retransmitting the packets so that it will efficiently reach the receiver with an optimized time period which we have given. So in that particular time period, it has to reach from sender to receiver so that it can prevent the congestion. So the next one is window policy, right? So in window policy, what we will do, we will select a repeat window, right? We have different windows mechanisms and techniques, right? Go back and window. So if we take go back and window, we have timer for packets where we set time. So whenever we are sending several packets again and again, although some may reach safely, some may lost during transmitting time, what we will do, we will check near the receiver whether it is received safe or not. That means the receiver has to give the acknowledgement back to the sender, right? So here we may occur the duplications, right? Because of that we will get the congestion. So to avoid this kind of repetitions or duplications, we will use selective repeat window in window policy so that we will try to send specific packets that are lost or it may be corrupted, right? So that we can use the window policy in open loop congestion control. So next one is acknowledgement policy, right? So acknowledgement policy is nothing but receiver will affect the congestion. That means receiver will send the acknowledgement, right? So if it is congested, the receiver cannot reply or respond, right? So because of that, every packet receiver receives, it has to slow down the sender and ask the help of the sender to prevent the congestion. So what in acknowledgement policy, what receiver will do, will ask help from the sender to slow down their packets while it is transmitting from sender to receiver. So here we have several approaches in this case. So where receiver can send an acknowledgement only when it is receiving the packet, then only it will send the acknowledgement, right? So here in acknowledgement policy, it will be having a special timer, so which will expire at particular time period, whether it receives or not the data packet from sender. So here the receiver will decide whether to send acknowledgement at that particular time or not. So here, by giving the acknowledgement, we will know what is the load of data packets or data flow in that particular network, right? So here, by sending less number of acknowledgements, we are giving less load in that particular network. So the next one is discarding policy, right? So here we have discarding policies, nothing but we have routers where we can prevent congestion at same time, right? So there may be no harm for the integrity of the data which we are going to transmit, right? So if you take an example of audio, some audio signals or audio data, right? If you are sending audio transmission, so if we have sensitive packets, so we can discard that at that particular time, so that the congestion will happen very less, right? So the quality of sound will be preserved, and we can prevent congestion by using this discarding policy. And the next one is admission policy, right? So here in admission policy, what we are going to check is quality of service. So how we are going to prevent the congestion by using circuit networks in admission policy. So here we have switches where we can flow, and we can check the what are the resources which we are required for the data flow before admitting it to the network. So we use a switches, and a router can deny whether it is going to establish a connection or it may not establish a connection, right? So if there is any congestion in the network, we can reduce the congestion by using all these admission policies, right? So these are about open loop congestion control. So the next one is closed loop congestion control. So if you see in closed loop congestion control mechanism, we are going to remove the congestion here, right? So we have different mechanisms or techniques where we can reduce the. So if you see here, warning bit or back pressure is there. So this is one of the mechanism where we can remove the congestion. So if you take this back pressure technique, what it refers is, it is like a congestion control mechanism where if we take a particular node, it will stop receiving data from the immediate upstream node. So this will cause the upstream node to become congested. So if we stop suddenly, it will be like congested. So what we will do, we can reject the data for that particular upstream. And here if we see the back pressure node to node, so if you see this particular slide, you will understand, like we have a special bit in each packet header, so we can cut off the traffic by using the source, right? So we will be monitoring the source, and we will be setting the acknowledgements for each bit, and we are going to adjust the transmission rate according to the source how it is monitoring, right? So here we have warning bits, that is like when we are sending the data in a particular flow or transmission media, the source will continuously monitor, and if there is any decrease in its retransmission, like transmission rate, so that it has to slow down, then only the transmission rate will increase. So here if you see the disadvantage, every router will have a path, right? So each path will take to certain destination point. So if we are setting a warning bit, so the traffic may increase only when no router was in trouble. So if a router is in trouble, then we cannot increase the traffic, right? So if you see here, in this particular nodes we have source, destination, and these are the four nodes where we are connecting point to point, right? So if we take the data flow in back pressure, so in this figure the node 3 will have more input data so than it can handle, because if we see in this technique back pressure, what we are going to do, we are going to apply like virtual circuit networks, so where we can send the upstream nodes in the flow of data, right? So if node 3, if we consider it as input data, so more than it can handle we are going to send the data. So what it will do, if we are sending more than its handling capacity, it will drop some packets in its input buffer, right? So and it informs to the node 2 here to slow down. So what node 2 will do, node 2 will check here whether there is any congestion. Because of congestion only, node 3 is asking node 2 to slow down its input data, so that the output flow of the data also will start slow down itself, right? So if node 2 is congested, what it will do, it will inform that to node 1 to slow down, because source is giving the data to node 1, node 2, node 3, node 4, and it reaches the destination, right? So if in between the node 3 is congested, so what it will do, it will give the request back, like it is pressuring the next node which is in backward direction, right? So it is giving the request to the node 2 to slow down. So node 2, if it feels it is congested, it is giving the request, that is it is giving the pressure to the next node which is the back side, that is node 1. It is saying to slow down, so that in particular time period they can reduce the congestion. So here they are applying the pressure for node 3 which is moving backward to the source, so that it can remove the congestion from backward till source, right? So this is the implementation of virtual circuit networks. So the next one is choke network here. So choke network, we have choke packets. So what is the general meaning of choke? That someone is holding tight, right? So if router sends a choke packet back to the source host, it will give the destination which is found on that particular router path, right? So if the original packet is tagged or it is set in a header bit, so what it will do, it will not generate any choke packets along the path. So it will forward usual way in a router. So if the source is having host, what it will do, it will reduce the traffic which is being sent in a transmission media, so that it can reach specific destination at less amount of time, right? So if you see in this example, you can see a choke packet present here, right? Yes or no? So if we take the choke packet, it is sent by a node, so that source to inform it that there is any congestion node present. So if we have to see what is the difference between back pressure and choke packet methods. So in back pressure we will be getting a warning bit, right, from one node to its upstream node. Although the warning may be eventually reaching the source station, it will be sending the warning bit. But in choke packet method, the warning is from router, not from the nodes till it reach source. Here it will be using a router, so which have encountered congestion, and it will give that to the source station directly. It won't go to node to node. So the intermediate nodes through which the packet has traveled are not warned here. So like in back pressure method, we are going to give warning bit to each particular node, 1 2 3, and then source node. But here what we are going to give directly the information to the source station by using choke packet here, right? So here we are using which type of protocol? We are using ICMP protocol. So if you see in this diagram, you will understand how it is directly interacting, right? So these are the nodes. So in back pressure, it went to node 3 to 2, 2 to 1, and it went to source. But here it went directly to the source by using the choke packet and the ICMP protocol. So the next one is the explicit signaling and the implicit signaling, right? So explicit signaling is nothing but packets are sent back from the point of congestion. So if a particular point or the node is having congestion, so the packets are sent back to warn the source through that particular signals. What is implicit signaling? The source will reduce the existence of congestion by making the local observations. That is how much time it is needed for acknowledgement to come back to the source, right? So if you see all these different policies in transport layer, network layer, and data link layer, we use all these different policies to prevent congestion. So if you see here, we have two different congestion controls. One is from TCP and other is frame relay here. So if you see here in this example, you can check like each CW ND is having the power, right? Exponent, right? 0 1 2 3, it will be keep on increasing its exponent, right? But if we see here, the frames are increasing, they one after other, right? From one frame to other frame, the frames are increasing, right? Yes or no? So in TCP, what we have, it is connection oriented, right? So what we will do, we will be slowly starting the exponential increase here. So we have an algorithm in TCP congestion control that is known as slow start here. So this algorithm is based on the idea of the size of the congestion window. So if we are denoting the congestion window as CWND here, so we are using one maximum segment size, that is MSS here. So we are determining connection establishment by using an option here as same name. So the size of the window will increase one after other each time whenever the acknowledgement is received in this diagram. Yes or no? So if same name implies in the windows, so the window will start slowly, then it will grow exponentially, right? So here, if we see in this diagram, we can see three simplifications here. So we have used segment numbers here, yes or no, instead of byte numbers. And we have assumed the CWND, and we have used the each segment, and we have used a sender window size here, right? That is CWND, right? So if the sender wants to send one MSS, then that means the sender is going to send only one segment. So after receiving, what receiver has to do, it has to acknowledge for segment 1, right? So the congestion window for this is increased by 1. So we are going to increase the power as 2 here. So now we are going to send 2 segments here, right? So after again receiving the acknowledgement for these 2 segments, again it is power increasing with 3, 2 power 3, right? so on. So the process will continue until the exponential limit it's reached, right? So this is slow start algorithm where we use in TCP, right? So in slow start algorithm, we are using the size of the congestion window increase exponentially. We are increasing until it reaches a threshold value, right? So if we take this as congestion avoidance, so how we are going to avoid congestion? So if you take here the CW1, 2, 3, so what it is doing is it is increasing one segment, not like exponentially. So here it is increasing one segment and it is receiving the acknowledgement until it reaches that particular threshold. If congestion occurs, it is trying to avoid or detect the congestion, right? So it is also based on the size of the congestion window, right? So how do we implement congestion detection? So we have a time period, right? For each slot, we have this particular time. If the data is being transmitted or not, it will wait till that particular time amount, right? That is called timeout here. So if it is detected, what we will do? We will start again new slot. Then again we will start that particular phase, right? So if detection is by 3 acknowledgements, what we will do? We will give a new congestion avoidance phase that will be started here. So if you take the TCP congestion policy here, you have timeout here, right? So if we find out the timeout, what we are going to do? We are going to add a new slot here, right? Where we can start the phase which will start, right? So after starting what we are going to check with 3 acknowledgements. So if we receive 3 acknowledgements, we can ask the congestion avoidance or congestion detection to help in this policy, right? Yes or no? So if you see here frame relay network here, so if you see all these frames, it is relying on the data which is coming from the sender, right? Or no? So if we are using this sender, we are using switches and we are using a direction of congestion. So if we take this switch, so here if a congestion occurs, we have to go back and we have to inform the sender by warning bit, right? So this particular frame is relying on this particular switch in this network, right? Yes or no? So in this frame relay, it is like forward, right? Forward we are going. So here if you see, we are going backward to the sender and here we are going to forward to the receiver. So here if we receive the direction of congestion, it is going to the forward direction and it is giving that information to the receiver. That means it is giving the warning message to the receiver that this particular point or switch is detected as congestion, right? So we have 4 cases in congestion, right? So if we take here A and B, one is sender and one is receiver. So if we take forward direction and backward direction, one is like no congestion, it may go backward or it may go forward. If the congestion is in the direction from A to B, it has to give the information 0 1 and 1 0, right? So here it is 0 0 and 0 0. So if it is from B to A, what it will do? The B which is having 1 before, in this case it will be replaced with 0 and 0 with 1, right? So congestion in both direction represent all bits as 1, right? So the next one is quality of service. So what is the main thing when we see quality of some services? We are going to check whether the quality is good or the transmission rate is better or the packets which we are transmitting, the quality of that particular packet, data packets are correct or not, there is any loss of data or not. So by using all these characteristics, we are going to check the quality is correct or not, right? So here we are going to see what are the flow characteristics and flow classes here. So if you see here the flow characteristics, it is mostly based on the reliability, what is the bandwidth, what is the delay, and what is the jitter here, right? So what are the techniques to improve the quality of service? So to improve that, we are going to give scheduling, traffic shaping, resource reservation, and admission control. So for scheduling, we know, right? We use queue, right? First in, first out. Yes or no? So we will be having a front end and we will be having a back end, and we have weighted queue and priority queue, right? Yes or no? So if we see here a queue, so if the back is filled, it will go to the front, right? So if it is full, what it will do, it will go and fill the queue. Otherwise, what it will do, it will discard, right? So if we take a priority queue, it will classify whether it is higher priority queue or lower priority queue, and then it will process the data, and the switch will be used as a mediator to the queue and the processor, right? So if we are taking weighted queue here, we will be having weights on each queue. According based on the weights, we will be turning it on or turning it off, and we are going to check with the weights of the queue, and we are going to send the data packets, right? So what is read here? Random early detection. So we are going to randomly detect early whether there is any congestion, and we are going to improve the quality of that particular service by discarding that particular packets which are filled in the buffer space. So if buffer is exhausted, it is filled. What we are going to do? We are going to discard packets from this. So this random early detection is one of a popular algorithm where we can use response to the lost packets from source, and we are going to give the information to source to slow down their data packets from sender to receiver. So here the lost packets are mostly due to the buffer. So if the buffer is so full, it overruns, rather than it detects the errors in a transmission, what will do, there is a loss of packets, right? So here the main idea of this detection is we are going to improve the time for that particular action before we are going to take. So before it is too late, we are going to set time for that particular action for that particular data packets from sender to receiver which we are going to transmit, right? So to determine when we are starting to discard, we will first check with the routers how it is maintaining the queue length, and how it is running, how it is setting the path. So what is the average queue length? Whether it exceeds a threshold or not. So all this we will consider, and we will check, right? So how we will shape a traffic by using two different methods. One is leaky bucket and other is token bucket here. So if you check here the leaky bucket here, we have the bursty data and the fixed rate data. So fixed rate data, what it will do, it will be fixed. There will not be any change in the peak data rate, right? Peak data rate and maximum data rate, there won't be any change. So the bursty time will be zero for this particular graph, right? So if we see the bursty data, it will have all the data rates, which is maximum, what is the minimum data rate, and what is the peak data rate, what is the average data rate here. So if you consider this as an example of one bucket where you are opening a tap to fill the water. So if the bucket is having any hole, right, so it will leak, right? So the flow will be very fast from the tap, but we have fixed flow here, how it will leak, right? So there may be a leakage of drop by drop, or there may be a certain level of flow where it will flow the water, right? So here you have constant rate where we can remove the packets by using this leaky bucket algorithm. That is, we know how much it broke, that particular bucket, and how much, what the level it is leaking, we will know in this leaky bucket implementation, right? So here the shapes is bursted traffic and that will be converted into fixed rate traffic by using the average data rate here, right? So here it will be dropping the packets if the bucket is full. Then only we will come to know whether it is leaking or not, right? So the token bucket will allow bursty traffic at a regulated maximum rate. So if you take here this example, here you are going to add the tokens in a bucket for each tick. So if you are adding one by one the token which we are taking, so if one token will be removed, then we will discard that particular cell, right? This is not about water or some liquid, right? We are going to use token here, right? So the next one is resource reservation and admission control. So we have buffer, CPU, time, bandwidth, all these are resources that can be reserved for particular flow of data where we can maintain the quality of service. So here we use different mechanisms for routers to accept or reject that particular flow based on the specifications which we set for the data flow, right? So that we call it as admission control here. So this is about congestion control and quality of services. So now we are going to see what is remote login or electronic mail and file transfer. I know you all know what is file transfer, right? Yes or no? What is file transfer? So file transfer protocol you all know, right? So we have three different protocols, right? Telnet, DNS, HTTP. So what is Telnet? Telnet is nothing but teletype network. So in this type of protocol, what we are going to do, we are going to enable one computer to connect to the local computers. So that will be used as a standard protocol. We are using TCP/IP. That is connection. We are going to establish the connection, and we are going to use one computer to connect with other local computers, right? So by using virtual terminal service here. So internet service organizations we are using to connect all the computers, right? So when we start the connection, that is known as the local computer, which we are going to use, and which we are connected with other laptops or computers. So if the computer is being connected, we will be using a connection that is called remote computer. So that is known as local computer, and that is also the connection which we have connected, that is known as remote computer. So while using the telnet operations, what we are going to do, we are going to use remote computer that will display by the local computer. So whenever we are using client service methods for telnet, so the local computer will use this telnet client program, and it will remote computers to use the server program. So for example, if I am operating the local computer, I can use the telnet client, and I can send the or share some data to remote computers which is received by the receiver side. So there what they will do, they will use the telnet server programs. So while logging, we have a local login and remote login, right? So whenever a user wanted to log in, what they have to do, they have to give particular keys which will be accepted by the terminal driver, right? So if you take a Linux or some other operating system, when you open it, you have a user ID and a password, right? So where you use a terminal to type your user ID and password, right? So that particular OS will characterize that ID and password, and it validate that particular combination of characters. If it is correct only, then it will open the required application which we are asking, right? So what is remote login? So in this process, users will log in into remote site and the computer, and it will uses the services that are available in that particular remote computer. So if there is any help of remote login, user will be able to understand that the result of transferring the data from remote to the local is successful. So if you take an example here, you have a terminal here and you have a terminal driver. So this is the operating system which handles the terminal. So if you wanted to open a particular application, you may set the username and a password, right? So if you give the credentials correct, then only it will try to open that particular application, right? So if you are using a remote login, how we are going to open it? So we will be having something called local computer, where the user will be operating and accepts the character, and the operating system will help to interpret that particular login credentials, right? So if the local computer will not interpret the characters, then it cannot open that particular application, right? Then we will use this telnet client. So what the telnet client will do, it will transforms these characters into universal characters. Then it will be called as network virtual terminal. So then this characters will be passed to the local TCP IP protocol stack. So whenever we use commands or different texts which are in front of this network virtual terminal, we will be traveling through the internet. So when it arrives at that TCP IP stack, IP protocol stack, what it will do? It will give that information to the remote computers. So whenever the characters are delivered in operating system, then only it will later pass this information to the telnet servers. So here the telnet server, what it will do, it will change that particular characters which is received from telnet client or local machine. So in this remote computers, what it will do, it will change those characters, and it will help them to understand what remote computer is going to read it, right? So the remote operating system will receive the characters from pseudo terminal driver, which is present in that diagram, right? Which is terminal space. So it is like a software which will pretend that the characters are coming from particular terminal. So here the operating system will pass the characters to the appropriate application, then only that particular application will open, right? So this is the diagram for that. So if we take the terminal, it will give the information to the terminal driver. So if the terminal driver of that particular login credentials, it doesn't interpret, what it will do, we use telnet client, and this particular telnet client will transform or interpret the ID or characters which we are giving, and it will give to the TCP IP stack. So from that stack, it will go to the network, and that characters will give from local to remote computers, right? So if the telnet servers interpret that characters, that particular application will open in remote computers also. So what is network virtual terminal here? We are using in telnet, right? This is the fundamental structure which we use to share by many different types of terminals, right? So we can create it to communicate between different types of terminals with different operating systems. So if we are using network virtual terminal, we can use different virtual terminals and we can use different operating systems to communicate between different organizations, right? So if you take telnet commands, we have prefix character here and we have interpret as command, and we have a basic format here, right? Interpret as command, command code and option code. So this is the basic format for telnet commands. So these are the advantages and disadvantages of telnet, right? So what telnet will do, it will provide the remote access to someone's computer system. So telnet here, it uses the users for more access here. So we have different problems here while transmitting the data, right? So here the telnet will help us to save a lot of time. So what is the disadvantage? It is like complex because we are using different operating systems and different terminals, right? So if we are a beginner, it is very difficult to understand, right? The data here we are going to send is plain text only, but it is not secured, right? When coming to security, any hacker can hack that particular data, right? So electronic mail is commonly known as email, right? You all know. So why do we use email? To send a message or to send an information, we use emails through internet, right? So to use email, what we need a recipient, right? For sending it, we need an email address, an email client and an email server. So we all know it has unique identifiers for each users, whatever format they give, right? So the format will be name at the rate and the domain and .com or .in. If you take the example of Karnia ID, your name or your register number with karnia.edu.in, right? Yes or no? So what is email client? So it is like a software program where we can use to send and manage emails. Like we use Gmail, Outlook and Apple mails, right? So that is email client here. What is server here? So if a computer system is responsible for storing and forwarding emails to the intended recipients. So if we are, for example, I am going to share a mail to all the students. So I have to know what is your unique identifier, that is your email ID, so that I can use Gmail or Apple Mail or Outlook ID to send that particular data, to forward that particular emails by using your recipient, right? So how do we send a mail? You all know we will compose a new message and we will give the to field and we'll add the subject and we'll write some body. We will attach whatever relevant files are needed. Then we will click on send, right? So that it will deliver the message to that particular ID which we have given, right? So we have a different features like CC, right? Which is a carbon copy, BCC, blind carbon copy, so that we can send that copies to or messages to multiple recipients, and we can reply all, or we can reply, or we can have a forward option to manage the conversations, right? This is how we will send the emails, right? So what is electronic mail? We are using through internet these services, right? So message is formatted in a manner so that we can mail that using internet to other users in any part of the world, right? So message will not contain only text. It can contain images, audios and videos data also, right? So the person who is sending mail is known as sender, who is receiving is known as recipient, right? So what are the components we have in email? user agent, message transfer agent. So if you take here the example, Alice is the user agent which is sending a data through a network to Bob, right? So when sender and receiver are sending email on same system, we need only two user agents. So if we are using different, like different organizations or communications, we can send. So here we are using message transfer agent, right? We are using here client and server, and we are going to use internet here. So the third scenario here we are going to use is we are going to use certain organization to transmit the mails, right? So the fourth scenario is we are using two different LANs or WANs so that we can give the client and server the messages, right? So this is about emails. So the protocols we will be seeing tomorrow class. I mean Saturday. Thank you. You all can leave.